Hello teachers, welcome back to the CBEST practice test. This is part 4 and number 31 says Antonio buys 4 notebooks for $3.50 at a store. The next day he returns to the store and exchanges the notebooks for 3 notebooks that have gone on sale for $1.75 each. Antonio uses the following expression to calculate the amount of money he should receive back from the exchange. So if you notice, he's multiplying 4 times the price. That's how much he paid. But then he subtracts the 3 notebooks that now he's going to get times the money that he's supposed to pay. And that difference is going to be whatever he gets in return. Okay, because he's only getting 3 notebooks. He says, which of the following expression could Antonio have also used? In here for letter A, it says 350 minus 175. That would be only if Antonio bought 1 notebook in the first place, returned it, and then got the other one, only one of them, okay? For letter, so that wouldn't make sense because he didn't get only 1. For letter B, it says 3 times 350 minus 175 plus 350. If you notice in here, he has 350 3 times plus the 350. So that shows the 4 notebooks. However, you're subtracting the price. Once he returns and gets the money back, you're subtracting the 175 times the 3 notebooks, because this, anytime that you have a plus or minus, remember that these 3 is multiplying both. That's called distributive property, okay? So that actually makes sense. For letter C, it says 4 times 350. Then it's subtracting 175, but only 1 time instead of the 3 notebooks that he got. So that doesn't make sense. He got 3 of them, not only 1. Then in here, they're multiplying 4 times 3, which is the number of items that he bought first and returned and then got later, minus the price of one times the price of other. Doesn't even make sense at all. That's just like multiplying notebooks with notebooks, and the cost times the cost does not show how much money he will get back. The next one, letter E, says 12 minus 350 plus 175. That 12 does not even appear in here, but I'm thinking that they multiply the 3 times 4 of the notebooks. But again, it's similar to this, right? Where you're multiplying notebooks times notebook, which does not make sense, so no. Number 32, Rudy needs to calculate 14% of 50. He does so by computing it in the following way. So what he's doing is multiplying 14 times 14 hundredths. Anytime, and we have seen it a little bit, is that anytime you have a percent, it goes 2 spaces to the back because it's percent. Cent means 100. In Spanish, actually, we say 100. Okay, so you go back 2 spaces. If you notice, point 14 is 1/10, 4 hundredths, but together is 14 hundredths, this is another way of expressing it. Okay, so let's look at each one. It says, which of the following methods could Rudy also use to determine correctly the percentage? So in here we have 14 divided by 100 minus 50. That does not show that it's equivalent to this. Also, if you remember before, we have multiply. Whenever you have a whole number and a fraction, you multiply straight so that you can maybe have an idea. And I don't know if this is how it's going to look, right? But 50 times 14, 1 times 100. That's, if anything, that's what it would look like if they had some kind of form like this, okay? But let's look. 50 divided by 14. No, 14, it's not even put into a decimal. You cannot work with it directly like that. So, no. This one, it says 14 divided by 50 times 100. Well, let's put it in this form to see if it makes sense. 14 times 100 divided by 50 times 1 is 50. That doesn't look equivalent, so it's not letter C either. The other one is 14 divided by 50. Again, they're using the 14 as just the way it is in the percent, and we cannot use the percent directly unless you're doing a proportion. But in here, 14 divided by 50, and then everything divided by 100, we have to have times, not divided by, okay? And the last one, as I mentioned, well, in here it says 50 times 0.14. 15 times 1400 is the same as 0.14, so 15 times 1400 is the same as 50 times 0.14, because this is 1400. It's in the tens, hundredths place, okay? So it will be letter E. Number 33 says, use the table below to answer the question that follows. And I recommend that you read the question first and then analyze the information. It says the table shows Sabra's grades for a class. For her overall average, the test average counts twice as much as the quiz. And the final exam counts twice as much as the test. Okay, so the final is twice as much as the test. To find her average, overall average, Sabra uses the following expression. So we see that the quiz is 83, the test is 79, and that counts twice as much as that one. And then the final is 88%, but that counts twice as much as this one. Okay, so this is what Sabra uses. 83 for the quiz, 79 plus 79 for the test, because it counts twice as much as this one. And then the final, 88, 88, 88, 88. And the reason is because that counts twice as much as this one. So if this is 2 times, then this is going to be 4 times. And then you divide by 7, because that's how we always get the mean average, if you remember from the first part of this practice. For the average, you always add all the items and divide by the number of items, which is 1, 2, 3, 4, 5, 6, 7. Okay, so one thing that I also would like to let you know, and I can't recall if I already mentioned this, whenever you're dividing by any number, and I'm gonna use any number at random. If I divide by 12, it's exactly the same as multiplying by 1/12. Okay, multiplying. If I'm dividing by in this case 7, is exactly the same as if I'm multiplying by 1/7, 1/7. Okay, so that's important to know. And now let's look at what it says. Which of the following is another way to find her overall average? So you have in here 83 plus 2 times 79 over 7 plus 4 times 88 over 7. So in here, you're adding all of them and dividing by 7. However, in here, the 83 is not being divided by 7. And I'm just gonna say that the way to have it correctly, for this one to be correct, will be 83 over 7 plus 2 times 79 over 7 plus 4 times 88 over 7. By doing the common denominator in all of them, that means that we're dividing just like we're doing in here, using only 1, okay? The next one, it has 83 plus 0.2 times 79 plus 0.4 times 88. This is actually, it means 4/10. It doesn't make sense because we're not working with either percents or anything like that. So that's also not correct. For the next one, it says 83 plus 2 times 79 plus 4 times 88. So far it looks good. Divided by 0.7. That can be tricky again because you have a 7 in here, but it's division. And why would I change it to a decimal in here? Just for no other reason, like not changing anything. You cannot change just one part of it and just have it make sense. So that doesn't make sense. In here, you have the 83, 2 times 79, 4 times 88, exactly the same, right? But you're dividing by 1/7. Careful with what I just said, because you might get confused and it says, oh, when you're dividing by 7, you can also put 1/7, but you have to multiply, not divide by 1/7, okay? In here we have 83 plus 2 times 79 plus 4 times 88 times 1/7. Whenever you're dividing by a number, it's the same as multiplying by that number in the denominator with a 1 in the numerator. So in here, the right answer is letter E. Number 34. Use the chart below to answer the question that follows. The chart above displays a relationship between the values of x and y. Given this relationship, what would be the value of y that it's missing? So we're missing a value right here, okay? What is that value? This is called the input, and then you do something to that input and you get an output, okay? And so what you can do is actually check a couple and see what's going on. For example, in here, the value of x is 1. To get a 3, you multiply times 3. And you can put a dot or the parentheses. 1 times 3 is 3. Let's check another one. And it's easier to check with the ones that are whole numbers. So I'm just going to do 2 times 3. Is it equal to 6? Yes, it is. Then there's another one in here. 3 times 3. You're always multiplying by the same or adding the same, depending on what it is. So in this is multiplication, multiplying by 3. 3 times 3, 9. So yes. So just to check, you can actually do the 3 times 1.5 just to make sure. And 3 times 5 is 15, carry 1. 3 times 1 is 3 and 1 is 4. There is one decimal number, so you just go back one space and it's 4.5. So yeah, it's also times 3. So now we can find out what the value of that one is. 2.5 times 3. 3 times 5 is 15, carry 1. 3 times 2 is 6 and 1 is 7. One decimal place, so you go back and it's 7.5. So that will be letter D. Number 35. A school district is proposing a 5% increase in the number of days in a school year. Currently, there are 180 days in a school year. How long would a school year be with the proposed increase? So we know that they want a 5% increase. So you're going to have to multiply and then add whatever the result is to the days that you already have right now. Okay, so if they want a 5% increase to the 180 days that they have right now. So the first thing that we need to do is that if we have a percent, we need to make it into a decimal. That's the first step. Always go, if there is no decimal, that means that it's on the right side, and you always jump 1, 2 times. If there is a loop, okay, a little swing without anything, then fill it in with a 0. So in decimal form, 5% is 0.05, and that's what you're going to multiply times the 180 years. Okay, so 180 times 0.05, multiply 5 times 0 is 0, 5 times 8 is 40, carry 4, 5 times 1 is 5, and 4 is 9. Now you're gonna go back 2 spaces, so go back, and that means that it's 9 more days. So if you have 180 plus the 9 days is 189. That's gonna be letter D. Number 36. Which of the following mathematical statements is correct? So in here, some people don't know which one is less than and which one is greater than. The first thing that I recommend that you do to be able to identify is put a 1 and a 2, and you know that this is smaller, right? So let's move that out of the way or erase it. So if you have this, 1 is smaller, 2 is bigger. So when the first one, the one on the left is smaller, you're gonna put the words less than, because 1 is less than 2. So this is just to show you, or this is a recommendation in case you don't recognize which one is which. Then, since the 1 is smaller, you're gonna put 1 dot. The 2 is bigger, you're gonna put 2 dots. And connect the dots, and then you say 1 is less than 2. So this symbol means less than. Then you switch them, and it can be any numbers, right? But it's easier to just use the smallest. So you know that the 2 is greater than 1. So these are, write the words. The 2 is greater, so it gets 2 dots because it's greater. The 1 is smaller, you only get 1 dot. Connect them, and then we say that 2 is greater than 1. So that's just to recognize the symbols, okay? Having that in mind, this symbol means then less than. And you can look at the whole number first, and then look at the fractions if you're comparing. So if I have that 3 is less than 3, well, maybe, and 3 is less than 2? No, 3 is not less than 2. You can just automatically eliminate that and forget about comparing the fractions for now. For letter B, this means greater, okay? So it says that the 3 is greater than the 2, and the 2 is greater than the 3. Oh, that doesn't make sense. So no, because the 2 is not greater than the 3. For letter C, 3 is greater than 2, makes sense, but the 2 is not greater than 3. So you can just eliminate that one too. 3 is greater than 3, and 3 is greater than 2. Maybe, for this one, we are sure that 3 is greater than 2, but let's check this one right here. In here you have 3 and 2/3. So 3 wholes, 3 whole cakes, and then 2 of the next one. So 2 of them. Okay, that's for the first one. For the next one, you only have 3 and only 1 of those. Okay, so let me show you in here. 1, 2, 3, and then only 1 of these ones. Okay, so is this, which has 3 whole ones and 2/3, bigger than 3 and 1/3? Yeah, so that one makes sense. Now let's look at letter E to see why it doesn't make sense. So the 3 and the 3 is less than 3. And then that 3 is less than 2. Just because of that, no, it's not true. So we cross that one out. Number 37. It says, use the mathematical statement below to answer the question that follows. 2/6 is less than something that we need to put in here, which is less than 6/8. Which of the following values, when entering the box, will satisfy the statement above? Okay, so what we need to do, there are two different ways of doing this, and one of them is to find the common denominator and then compare just the numerators. If you want to do it that way, that's fine. Or you can just simply start looking at how would that look. I'm thinking that if I simplify this first number, which is 1 divided by 2 and divided by 2, right? Remember, to simplify, you always have to divide the numerator and denominator by the same number. So 2 divided by 2 is 1. 6 divided by 2 is 3. And that should be less than the number that we're looking for, which also should be less than, again in here, 6 divided by 2 is 3. 8 divided by 2 is 4. And so this is 1/3, should be less than the number that we're looking for. And so this should be bigger than this one, but smaller than this one, okay? Now, if you're thinking of the picture of that it creates, this is thirds. You have only one in here. This you have fourths, and you have 3 of them, okay? And so 1/4, it's actually smaller, because if you cut it into four pieces, it's a little less than 1/3. So letter A does not make sense, okay? 1/4 would look like that. Okay, so that's smaller than this one. It has to be bigger than 1/3, smaller than 3/4. Letter B. We have 1/3, which is equal to this one. But in here, it doesn't say 1/3 equal 1/3. So automatically that is no. They cannot be the same. It has to be bigger than 1/3. 1/2. If you're thinking about this with the picture, 1/2 is bigger than this one, right? And it's smaller than this part because you have only 1/2, and this one has more than that. Okay, so looks like it's letter C, but let's look at the other ones just to make sure. 3/4. 3/4 is exactly the same as this one. So no, that's not, it cannot be equal. It has to be smaller than this one, but bigger than this one. And then 9/10. 9/10, you actually have to cut it into 9 pieces. So I'm going to cut it in half first, and then I'm going to try my best to do 5 equal pieces on the top. Yikes. And then 5 equal pieces on the bottom. Whoops. And then you have 9 of them, okay? 9 of them. So if you notice, this is bigger than this one, but no, it has to be bigger than this one, but smaller than this one, okay? So that's why it's not letter E. So with this, we conclude part 4 of the CBEST. Remember that if you know other teachers who would benefit from learning this material, please pass it on, share it with them, and don't forget to subscribe, give a thumbs up, and I would really appreciate that. Thank you. I hope you pass the test.